Well, hello and good evening. Aeon Mellon, everybody. My name's Joseph. People call me Mr. Mellon. So we are marking a massive milestone today. I'm making this impromptu video to celebrate a brand new paper. I read an article from MIT that had covered this, and I'm going to have a link to that article in the description. But there is a paper that was published in the Proceedings of the Royal Society A titled On Computing Quantum Waves Exactly from Classical Action by Winfried, Lohmiller, and Jean-Jacques Slotine. And I hope I pronounced those names correctly. I apologize in advance if I did. Well, I apologize if I didn't. But first and foremost, I have to send a boatload of gratitude to both of them. Not only for the absolute brilliance of the paper, but for their swift response to my email as well. That's exactly what cooperative, forward-moving physics looks like. I am thrilled to be able to document this moment. It's wonderful. What they end up showing is mathematical proof that the Schrödinger wave equation can be constructed exactly, but using classical multi-valued action and classical fluid density. They completely bypass the need for stochastic quantum noise and semi-classical approximations. They're treating the quantum mechanics fundamentally as a hydrodynamic phenomenon. And if you've been following my research, you know that this is the exact mechanical substrate described by the quantum space mechanism. So it's characterizing space-time as a viscous fluid. So they are treating quantum mechanics fundamentally as a hydrodynamic phenomenon. And it's great. Finally, somebody else sees, yes. Let's look at exactly what they used and where it maps into QSM. Now, first and foremost, equation 1. So go ahead and pull up QSM if you need a second or whatever. Pull up QSM, go to page 11, look at equation 1. So what you'll see is the entropic action integral. This is where I took the exact action principle and expanded it to include the entropic penalty for geometric deformation. So what they're doing is they're operating on the very foundation that was laid out on how the vacuum itself responds to movement, why we even have inertia in the first place. Number 2, tracking the fluid's flow, tracking the probability density over time. They rely heavily on classical continuity equation, which is their equation 1.4. Go ahead and go to page 15, equation 12. And this is the modified Navier-Stokes equation, where they're mapping the probability flow. QSM equation 12 shows the comprehensive fluid dynamics of the vacuum substrate itself. It proves how the vacuum acts as a shear thickening fluid that governs exactly how that flow that they are tracking. So, number 3, the probability waves. They're one of the biggest ones that I guess, the Schrödinger equation has been around for a while. Okay. But what they show in here is that the quantum wave amplitude is derived directly from the square root of the classical fluid density. So if you go to page 33, equation 79 of the 108-page QSM, I show this exact physical reality. The probability wave is physically the inverse of the local vacuum viscosity gradient. Where their equation looks at the density of the fluid, QSM equation 79 defines the physical mechanism as the hydrodynamic shear of the vacuum itself. It is the exact same phenomenon mapped into the mechanism. And the hydrodynamic reality of it all. Okay, yeah, we're in a sea of space. Oh my. Finally, to see how all of it ties together, go to page 98. Section 54 of the document shows hydrodynamic quantum mechanics. What they did was their entire premise, solving the Schrödinger equation exactly from classical mechanics without quantum noise, is the rigorous mathematical execution of the reconciliation that I detailed in section 54. They proved that the math catches up perfectly to the mechanism. That's what's up. That's great. That's why I'm putting this channel here, and that's why I'm having all these videos put out here. Is so finally we can have a record of all of this. We can get people up to speed. We can get eyes in where they need to be, and we can start understanding things a bit more correctly. So I'm going to talk about a whole bunch of things, but for now, this is my focus for now, and it's finally coming to fruition. Finally, thank you, God. It's wonderful. I'm so excited. So, but that being said, anyhow, I appreciate you guys watching. Thank you very much. Thank you for following along. I hope you're staying blessed in these trying times. I know things are going crazy out there in the news and all that other stuff, but don't pay attention to half of it. We're going to make it one way or another. So, and just have a little faith. If you don't, I'll have faith for you. But that being said, you guys have an awesome night. Thank you for watching, and stay tuned and be blessed. Have a good night.